All to Rankplus JEE English. I hope you all are fine, and in today's video we are going to cover rotational motion. This chapter is very important because we'll be going to use the important concepts which we will study in this chapter in various other chapters, as well as if you find if you are solving the previous year questions, you will find multiple questions are coming from this rotational motion, right? And there was so much demand for this chapter, so today we are going to cover these 9 topics I have segregated for you. So first of all, we will discuss the basic concepts of the rotational motion. After that, we will go to the torque, the concept of torque, and I'll teach you in my unique way, which is there in the 9th topic, my special technique through which you can solve any numericals related to the rotational motion. So this video going to be similar to the videos which I have posted on this channel earlier. Like I'll be discussing each and every topic in a pattern wise manner, in which you will be seeing that there is no other formats or other form of questions will come in your exams. Okay, so let me begin this chapter without wasting any time. So first of all, we require to know that what is rigid body and why this rotational motion concept comes only into the rigid body. So first of all, you need to understand that rigid body means that any 2 points, if I am taking on an object, the distance between those points does not change, right? So I'm considering randomly one object, and on that object I am considering 2 points P and Q. I'm saying that the distance between these 2 points, the random points which I have chosen here, P and Q, the distance between these 2 points will remain same, respective what force I'm applying on this object or at which speed this object is moving. You can also say, if I'm telling you that this object is rigid body, it means that distance between 2 points is constant. There is another way to define this rigid body. You can define it in a manner that the relative velocity between these 2 points are 0. Relative velocity between 2 points are 0. I have taken these points on the body. Right. If I'm telling you that this point is having a velocity in this direction, and let me take an angle theta here, theta 1. So if I'll resolve this velocity component in this direction, I'll be getting Vp cos theta 1, right? This is the velocity which will I get, and assuming that there is another particle out there Q, and this particle is having a velocity Vq here, the angle for this is theta 2, and if you resolve this Vq, you will get Vq cos theta 2. And I am now, according to me, which I'm telling here, that we have to take relative velocity between 2 points to be 0. It means that this Vp cos theta 1 should be equals to Vq cos theta 2. Vp cos theta 1 should be equals to Vq cos theta 2. Okay. So these are 2 points which I'll be considering if I have to see that whether this object is a rigid body or not. So I'll be considering only these 2 things. Okay. And according to the definition, this says that a body can rotate with all its parts locked together and without any change in its shape. There will be no change in its shape. I hope that this thing is clear to you. Is this thing clear? And if this thing is clear, we can move forward towards that why we are only considering that rigid body is required when we are dealing with the rotational motion, right? So first of all, you need to understand the basic difference between the rotational motion and the circular motion. We have two types of motion, and I always tell my student that actually the circular motion is the most important type of motion which you have to study, and ultimately you will see that from the circular motion you will have multiple branches according to the different conditions which we will be applying here. So first, I'll explain you a basic difference between a circular motion, difference between circular motion and rotational motion. Difference between a circular motion and the rotational motion. So if I'll have to consider a circular motion is very, very simple. There is no conditions at all. The only condition is that motion in which the path is circular. Motion in which the path is circular. Just simple. But for a motion to be a rotational motion, there are some situations, there are some conditions which must be required. And I can also tell you that every rotational motion is basically a circular motion, but every circular motion is not a rotational motion. Every rotational motion is a circular motion, but every circular motion is not a rotational motion. Okay, basically rotational motion is a subpart, you could say, for a circular motion, right? Hari, working hard. Is it clear, my dear? So any type of motion in which the path is circular, we will be considering that motion to be a circular. Okay, it's very simple. If I'll tell you that one object is moving, or I'll take one example to explain you that this is circular and this is, let me take one thing. There is a board in which I have written physics, and there is an arrow this side. This is a road, and we have welded this road with the board. Okay, now imagine there is some ring out there. It means that it can move here and there, and if I'm applying a force on this object, what will happen? If I'm applying a force, the complete this complete object is moving, right? I'm having this one with me. Assume that, is it clear? Okay, I'll take another thing in that. Let me put some newspaper so that it will be visible to you. Okay, I think that it's now visible. Now I think it's visible to you. Okay, so I'm telling you that I'm having this kind of object. This is a particular rod. Here I'm having a rod, and at this point it's welded. Okay, you can consider that I have welded this. Now if I am moving this, if I'm moving this, if I'm applying some force at this point, then what will happen? This object all together move, right? This object all together will move together. I have to paste it. Like, you have to consider this as a single object, as a rigid object. So if I'm moving this, then this whole object is actually moving, right? Whole object, when this whole object is moving, I could say multiple things. Let me draw this for you. So I'm telling you that if I'm moving this object completely, okay, then each and every part, you can, if each part of an object, if each part of an object is moved by same angle, then you will say that this is a rotational motion. This kind of motion is known as a rotational motion. It happens only in the solid body. Why in the solid body? Because in only the solid body, all the points on this object is moving. Let's, all the points on this object is moving and subtends equal angle. If I started to measure the angle here, I will be getting the same angle for any points. If I'll consider this point, this angle, this point must have moved the similar angle as compared to these 2 points. Okay, but if I'll be taking another example, let me draw another example here. Now this time it's not welded. There is another ring here. Okay, there is another ring here. And if you are moving this, if there is a ring, then what will happen? This board will not change its shape. It will remain horizontal to the surface. Okay. This is basically a circular motion, but not rotational. This is an example of circular motion, but not rotational motion. It's not a rotational motion. Why it's not a rotational motion? Because if you considered any 2 points randomly on this object, right, from the initial position and the final position, you will see that these 2 points may be subtending different angles. But if you consider this object, then you will get to the same angle subtended by any point, right? So if I'm telling you that this object is getting it's moved by an angle theta, then any point on this object is moved by an angle theta. You can consider it randomly and any point. All the points have been moved by angle theta. You can take reference from anywhere. Okay. So this is basically a rotational motion. Plus, I can say that it's also a circular motion. So rotational motion happens only in, it happens only in a rigid body. It occurs because this is a phenomena that occurs only in rigid body. It occurs only in rigid body. And if you see like if you see here, then here I can say that basically it's not a rigid body. This the signboard remains horizontal to the surface. Here we have put a ring out there to like it can move anywhere. So it's a circular motion, but it's not a rotational motion. It's not a rotational motion. This is just a basic example, get you acquainted that what is circular motion and what is the rotational motion and how we can differ them. But mainly when we are a JEE aspirant, we have to mainly focusing on how to solve the numericals, and we have to be more concerned about it, how to fetch the data from the numericals. And when we are fetching the data, it's not important that we are only fetching the data, but it's also important that after getting the data, we must know that how to apply the concept to get the answer required, right? So let's move. And here it's a basic difference between the rotational motion and the circular motion. So every rotational motion is a circular motion, just as we see here. This was the rotational motion because it happens in the solid body, and every point on this object is moving by the same angle, right? So this is also a circular motion. So I am saying that every rotational motion is a circular motion, but every circular motion is not a rotational motion. This is what we have seen in the previous example, and these two statements are very, very important for your assertion and reasoning, right? And now if we have to differentiate between a circular motion and the rotational motion, there are multiple ways in which we can differentiate. The first thing is about the path. If I'm talking about the path for the circular motion, the path must be circular, but for the rotational motion, it's spin around an axis. There must be one fixed axis, or there must be one fixed point about which the rotational generally happens. Take an example. If I have to rotate this pen, I am holding this pen at a fixed point, and if I'm holding this pen at this fixed point, if I'm rotating this, if I'm moving this pen is basically fixed at this point, and all other points are moving, right? All other points are moving, but one point is fixed. Similarly, if you are having one ball, or you are having the planets out there, there will be one axis. You can take imaginary axis as well. There is one axis. Using that axis only, the rotation will happen, right? Even if I'll spin this ball, I'm a very good bowler. So if I'm spinning this ball, then this ball is actually creating a random axis around which this ball is rotating. Without any fixed axis, rotation can't happen. Okay, it always happens around one fixed point or an axis. Second, if I'll talk about the axis of rotation, so for circular motion, it is fixed. The axis of rotation is basically fixed and it's outside the object. And for the rotational motion, it can be inside or the outside. Just as we saw in a ball, it is inside the object. And if I'm like having, I'll make a pendulum out of this box, out of this ball, then what will happen? It will goes outside the ball. Then the third one is the distance from the axis. The distance from the center remains constant here, but here the distance can vary, depends on the shape. Third one is the type of acceleration. It includes the centripetal acceleration. It includes, it also involves the angular acceleration. Examples are satellite orbiting Earth, cars on a curved road. Here, spinning top, Earth rotating on its own axis. Right now, we are more concerned about data, basic data, which is required. Basic data, the basic terminologies, or I would say required to move forward when we are dealing with the rotational motion. So first of all, we must understand that when we were studying the motion data basically deals with first one, the distance or the displacement. Distance and displacement that shows us that how much position gets changed, right? In a translational motion, basically we are more focused about that how the position gets changed in the space. But in the rotational, we are more concerned about that how the object is basically subtending the angle, or I would say that it's rotating. So here my main focus was on distance. Consider distance and displacement as same, because here I'm considering the translational data for a translational motion. And if I'll consider the rotational analogous to the translational, we have another thing here, distance or displacement. Let me take a displacement, it is more popular. So I'll take a displacement out there and I'll take this as S. So here what we will have for a rotational analogous to the displacement, we have the angular displacement. Here we are having an angular displacement, and for the angular displacement, if this is theta, this is S, this is the radius. So you could write theta is equals to S by R, and S will becomes theta R. Theta is basically the angular displacement, and the unit of theta you have to take in the radian. SI unit here will be radian. And here SI unit is meter. Okay, second thing. The first one is displacement. And after the displacement, what is the most important data which you have to consider when you are dealing with the motion? The another important data is the velocity, right? And we all know that velocity is basically the rate of change of displacement. So I could write velocity V as ds by dt. And here, if I have to write the rotational analogous of what we have already studied, you could consider the angular velocity, and the symbol for the angular velocity is omega. And omega is basically the rate of change of angular displacement. It might happen that you will be getting an equation for the angular displacement similar to what we were getting when we were dealing with the numericals related to the displacement. And we have to get the velocity, we have to differentiate that and then put the values of t accordingly, right? Similarly here, if we have to calculate the angular velocity, we have one option to either differentiate it. There is another thing that if we have to get the relationship between this and this, I could do as displacement is equals to theta r. If you differentiate this, you will be getting ds divided by dt. That will be equals to velocity, and here that is dt divided by dt r. So you will get v is equals to omega r. So this is also an important relationship which you have to remember, right? And now Third, third is acceleration. So acceleration, we know it's about the rate of change of velocity, dv by dt. And here, the similar analogous, the rotational analogous of the acceleration, we have the angular acceleration. And angular acceleration is basically denoted by a symbol alpha. So alpha will be equals to d omega divided by dt. And here, if you are more if you are observing here, what is happening, we are keeping here the linear data, rotational data, and it is multiplied by r. Linear data, rotational data multiplied by r. So what if I have to get a relationship between the a and the alpha? I can easily get using a is equals to alpha r. I hope that this thing is clear. So these are basic data which is required when we are dealing with the rotational data. We must know the displacement, we must know the velocity, we must know the acceleration. Here, the terminologies get changed. Here we will talk about the angular velocity. Here we will talk about the angular acceleration. Okay, I hope that this thing is clear to you. And what is actually happening here, if there is object, let me draw one for you. ये हमारे पास है. Okay, now what will happen? What will happen here if I have moved this object by an angle theta, right? The velocity with which it's going, we have to take it omega. Omega will be equals to d theta by dt, or you could easily replace it by theta by t. Now, we were having the equations of motion. We can transform those equations of motion in rotational equations as well. So now here we have rotational equation of motion. So we were having S is equals to, or right, let's start with the first, V minus U equals to AT. The analogous to this in the rotational format is omega minus of omega naught is equals to alpha t. Second one, S is equals to ut plus half at square. Analogous to this is theta is equals to omega naught t plus 1 by 2 alpha t square. Third one, v square minus u square is equals to 2as. So analogous to this, you will have omega square minus of omega naught square equals to 2 alpha theta. So these are basically three equations which we will use. Okay, now I hope that all the arsenals are ready. Now it's time to fire. Now I hope that all the arsenals are ready. All the basic arsenals are ready. This is the basic data which you have to know, right? I always tells you, whenever you are basically studying physics, physics is all about the data which you can get either from the observations from the real world, or when observing the question. You have to first get the data out of the question, and after that you must know that how to apply that data. So before applying, we must know some basics. This is the basic about the displacement, angular displacement, the basic about the angular velocity, the basics about the angular acceleration, and the basics about the rotational equations. I hope that this thing is clear to you. Is this thing clear? Tell me, is this thing clear? Sir, I am solving HC Verma, Ashwin is saying an NCRT for chemistry. Huh? Okay, you are solving physics for HC Verma for physics and NCRT for chemistry along with 2017, 18, 20, 23, 24 for both. Is this enough for 99% for JEE main second attempt? Uh, Ashwin, I have one question for you, that why you are targeting the second attempt, that is the April attempt. Why not this January attempt? You know one thing, that you have to change your story, because if you have a target of April in your mind, then what will happen? You will not be striving the way you have to for your January attempt, right? I always want my student to go for what? This January attempt, because this January attempt is very, very important, because once you score very well in this January attempt, your confidence will rise, and that will going to help you to boost more score in your April attempt. So it's better. Sumit Daya, hello. No, but first you have to target this January attempt, then only go for the April attempt, and keep your targets like in January attempts you have to cover these many topics, the high weightage chapters you will be covering, or whatever I'm going to teach you will be covering, right? For the January attempts, keep that thing. And other than that, the HC Verma for the physics, it's sufficient. Plus, in addition to that, you can go for the previous year questions. I have also included the previous year questions in this lectures as well, for like from 23 and 24. I have already taken, right? So you have to solve those previous year questions and do not look for the solutions instantly. Wait for sometimes, wait for one day, or then only go for the solutions. And if you like stuck somewhere, yeah, then come directly to me. That, sir, I'm not able to solve these questions. What is the problem? What is the root cause of the problem? Because what will happen if you instantly see the solutions, then your brain cells would not get developed. You know what physics is? Physics is when you are solving the physics questions, it's like solving the puzzles, and when you solve the puzzles, your brain cells, the neurons, all gets activated, all gets exercised. So when you are doing the exercise, you have to cross your limits. If you're not crossing your limits, it will not help you to gain your muscles. Similarly, it will not gain to help you for getting more marks. If you really wants to improve your scores, you have to do the challenging questions, because when you are solving the challenging questions, what happens generally is your confidence increases, and when your confidence is high, I would definitely tell you that you are going to ace the exam, right? So let's move forward. We are having a question here. The motor of an engine is rotating about its axis with an angular velocity of 100 revolution per minute. Okay, there we will learn very a few things about the angular velocity. It comes to rest in 15 seconds after being switched off. Assuming constant angular deceleration, calculate the number of revolutions made by it before coming to rest. So this question is for you. Please try to solve and give me the answer, that what will be the answer of this question. This question is asking you that you have to calculate the number of revolution. You know what does revolution means? If there is a wheel, if there is a wheel of radius r, and this wheel is rotating, if there is a wheel of radius r and this wheel is rotating, then what will happen? This wheel will rotate, and after some time, This is radius r, this is radius r. Okay. No, what? No, I'm telling you that if this object is basically rotating, then if this object is completing one round from here to here, then you know what? How much distance is covered? 2 pi r is equals to one revolution of this wheel. So 2 pi r is basically equals to the one revolution of this wheel. Hello, movies world. My plan is enough for 99 percentile. Yes, your plan. See, planning is important, but only doing the planning will not give you result, because all of us have some potential, right? And if you have very good plan, you will see that you will attain whatever result you are having. But the problem is, you will not be going, the chances of not following the plan is very high. So it's better, rather than making a plan, make a beautiful story and follow that story. That yes, you have to do it, and you have to do regularly, daily, at least 6 to 7 hours study, other than the videos you are watching, other than the various resources which you like usually refers. Self study, basically I'm talking about 7 hours, right? At least you have to attain that level. So this is the one revolution 2 pi r. When a linear distance is 2 pi r, we say is that the wheel has rotated by a one revolution. So let me fetch the data out of the question, because according to me, always data is important. These lines are not important for me. So solution: the motor of an engine is rotating about an axis with an angular velocity. So I'll be considering the omega naught as 100 revolution per minute. 100 revolution per minute. I have to change this 100. One revolution is equals to 2 pi. One revolution is equals to 2 pi radian, divided by 1 minute is equals to 60 seconds. You can cut this to 3. So you will be getting omega naught as 10 pi by 3 radian per second. And you know, omega will be equals to 0 radian per second. The time it takes to comes to rest is 15 seconds. So these are three important data given to you. Now, using this data, you can easily find out a theta, because we know that theta is equals to omega naught. Okay, we have to find out alpha here to get theta. Alpha will be equals to omega. This is basically the deceleration. Minus 2 pi by 9 radian per second square we will get. Now, if I have to find out theta, theta will be equals to omega naught t plus 1 plus alpha delta t square. So you could get 10 pi by 3 into 15 minus of 1 by 2, alpha is 2 pi by 9, t square, 15 into 15. So theta will be equals to 50 pi minus of 5,025 pi. So you will get 25 pi. Are you getting this? Are you getting this? Theta is equals to 25 pi. Are you all getting this? Can I crack movies world with only one shot? Yes, you can. One shot is enough, but other than one shot, you have to solve previous year questions. At least after watching this one shot, go for at least 5 years PYQs. If you're not able to solve 5 years PYQs, at least solve 3 years PYQs. If you are not able to solve 3 years PYQs, I would be suggesting at least solve 10 sample papers, and 10 sample papers must be from a very good institute. Okay, at least that level you have to attend. Now this is basically the theta, the distance covered by it. But here what we have to find out, we have to find out the number of revolution. To get the number of revolution, we can get by theta divided by 2 pi. So you will be having 12.5 revolution. Okay, so 12.5 revolutions. So please upload NCRT. Navadeep, Deepu, beta, please come live in every class. You will get 100%. You will get. So you are asking me every time. I have already shared one Google Sheet with you. In that Google Sheet, you are basically getting a direct link for all the one shot which I am covering. You are getting a direct link for all the handwritten notes which I'll be sharing there. You will be getting all the there in that PDF. You will be getting complete a direct link to this PDF which I'm teaching here. And similarly, there only I'll put all the highlighted NCRT to like for a quick revision. At least solve the NCRT for the modern physics. So I'll be uploading the modern physics NCRT there. You are coming late. Okay, now you can continue now, right? So be there, you will get it 100%. It's already being prepared. Okay, the Google Sheet in which video? For getting the Google Sheet, you have to first join our Telegram group. In Telegram group, I have already uploaded the Google Sheet. In that Google Sheet, you basically you just need to download that Google Sheet, right? In that Google Sheet, you will get a complete schedule for the physics classes, a direct link for the YouTube classes, a direct link for the PDF which I am teaching here, a direct link for the handwritten notes, a direct link for the practice sheets, DPP sheets out there. Because once you watch this video, only watching this video is not enough. You have to solve the previous year questions. You have to solve the DPPs. Then only you can be confident that whatever question will come in your exam, you are able to solve it, right? Now let's move to the another question. Here we are having another question. Starting from the rest, it means that basically I already told you that whenever you are reading the question, the first and foremost thing what you have to do is fetch the data, get the data like what you could say. There is one example for that. Like once who sees anything, but you have to basically what is required, you have to see only those things. So whenever we are reading the questions, we have to get the data which is required for us to solve the question. So here, starting from rest, that means omega naught is equals to 0, takes 5 seconds to attain the maximum velocity. So there is an maximum velocity which is 400 RPM. RPM is basically revolution per minute. You have to change this revolution per minute into radian per second. So 40 pi by 3 radian per second. Okay. Now, assuming constant acceleration, find the time taken by the fan in attaining half the maximum speed. Half the maximum speed. So from here to here, V omega required is equals to 20 pi by 3 radian per second. So basically, you have to find out the time, at how much time it will take from 0 to here. So for doing that, you have to get one more thing, one more data is required, and that data we can easily find out using, okay, now there is another data. A fan takes 5 seconds. So we have this. Using these three data, 1, 2, and 3, you can find out the alpha. So alpha will be equals to omega max divided by time. Forty 8 pi by 3 radian per second square. Okay, so alpha is 8 pi divided by 8 pi divided by 3 radian per second square. So from here to here, you are also having one alpha, which is 8 pi divided by 3 radian per second square. See, like, I always take feedback from the student that where they are getting stuck, why they are not able to solve the numericals, right? So based on the feedback of the students, I'm telling you that some students face issues while dealing with the rotational motions numerical. The issue is not that this chapter is very, very difficult. The issue is that they are thinking that this chapter is a complete unique chapter. This chapter is not a unique chapter. This chapter is basically an extension of all the concepts which we have studied earlier. Like here, we will be studying the kinematics. What I'm doing here is the extension of the kinematics part. You already have solved the questions multiple times related to the equations of motion. So here what I'm doing is I'm using the equations of motions only, right? Isn't it? So you start thinking in terms of kinematics. You start thinking in terms of the other concepts which might come here, and you will see that you'll able to solve these questions in a very few seconds, right? So here we have alpha is equals to 8 pi by 3. Okay, now we have to get the time, right? So to get the time, we know that omega v is equals to u plus 18. Omega required is equals to omega naught plus alpha t. Omega naught is 0. So to get the time, omega required divided by alpha, and omega required is 20 pi by 3 divided by 8 pi by divided by 3. So you are getting 2.5 second. Are you getting that? 2.5 second. Are you all getting 2.5 second? Tanishk Mishra. Okay, thank you, Tanishk. Dhanu 3. Hello. Okay, Mom's Grace. Hari, are you there? Working hard? Are you there? Mitra? I hope that this question is clear. First and foremost thing, what is required is to get the approach correct. Because once your approach is correct regarding solving numericals of rotational motion, you'll able to solve each and every question within few seconds. Because what generally happens when you are seeing a question, the approach must come within 10 seconds. If approach is not coming within 10 seconds, either you are not trained well or the question is very, very difficult. This is the only two things. Either you are not well trained or the question is very difficult. Then only you will not get a approach in 10 seconds. But for the easy question or the median question, and for getting you well trained, the first and foremost approach is that you have to start thinking in terms of the concept which we have studied earlier. Rotational motion is all about rotation. In rotational motion, we are not learning any new concept. We are not learning any new concept here. We are just relating the concept which we have studied earlier to the concept of the rotational motion type, right? So we will be dealing with kinematics. We will be dealing with kinematics. You have to relate the kinematics concept which you have studied earlier with the terms of the rotational motion, right? The displacement will get changed into the angular displacement, the velocity gets changed into the angular velocity, the acceleration will get changed into the angular acceleration. So these are the only things which you have to do. The second thing is Newton's laws of motion, NLM. Same here. The force, there is analogous to force in the rotational motion. We have the torque. For the momentum, we have the angular momentum. So there are similar types of terms out there. There are very subtle difference between the terms which we have studied in Newton's laws of motion and which we will going to learn in the rotational motion. But what I am going to tell you is that before we proceed, is that you do not need to think in terms of isolation when you are dealing with rotational motion. You have to be well amalgamated, or I would be saying that you have to connect all those dots, whatever we are studying, with the dots which I am teaching you. So kinematics, Newton's laws of motion. The third one is the work, energy, and power. So all these concepts will get mixed together. Then you will be able to clear each and every question related to the numericals of rotational motion. Other than that, we have also a similar concept which is center of mass. I'll be taking center of mass separately because that topic is altogether is a very huge topic, so it would take a considerable amount of time from this class. So I would not want to distribute that time to the center of mass because that topic is important, but it's not being required or not being asked by the student. So that we are facing issues in the center of mass. I'll take it separately, right? So basically you have to uh, see every question in terms of these. If you are able to see each and every questions in these terms, you will able to solve, you will be able to get the correct approach within 10 seconds of any questions related to the rotational motion. Let's solve another question. In this question, a bucket is being lowered down into a well through a rope passing over a fixed pulley of radius 10 centimeter. So there is a pulley of radius 10 centimeter. Okay, and we have a rope. Assume that the rope does not slip on the pulley. Find the angular velocity and the angular acceleration of the pulley at an instant when the bucket is going down at the speed of 20 centimeter per second and has an acceleration of this much. Okay. This is the bucket we are having. And this bucket is moving with an acceleration of 4 meter per second square. The speed is 20 centimeter per second. Okay, now everything is clear. What you have to find out? You have to find out the angular velocity. That means angular velocity omega and angular acceleration alpha. Okay, so this is what you have to find out. The question is very, very simple. As we know that we have been provided with the linear data, right? We have we have also a value of here 10 centimeter. So according to the question, we know that v is equals to r omega, and to get the value of omega, we have v divided by r. The value of v is 20 centimeter per second, and you can replace the value of r as 10 centimeter. So omega will be equals to 2 radian per second. Are you getting this value? Are you getting this value? Similarly, for getting the alpha, we have another relations. That A is equals to R alpha, and alpha is equals to A divided by R. This A is equals to 4. This time this is in meter per second square. The R you have to keep 0.1 meter this time. So you will get alpha is equals to 40 radian per second square. I hope that this is clear. Is this clear? Unknown gamer, what are you saying? Sometimes student feels that's why I'm telling you. Sometimes student feels that rotational motion is a very difficult topic. Rotational motion is not a difficult topic. Rotational motion is basically an extension of the topic which we have already studied. There you will find a kinematics questions. There you will find numericals related to the Newton's laws of motion. There you will find questions related to the work, energy, and power. The just what you required is to have the same analogous, right? You have to think in terms of the concept which you have already studied, and you have to relate those concepts with the analogous of the rotational motion. This is what you have to do. Let's move. And now it's time to learn a new topic, which is, I think, clear, right? So now let's learn a new topic, which is the torque. This is also known as a rotational force. This is also known as a moment of force. And sometimes if this is a pure form of torque, we would say it as a couple. Okay. So what does it actually means? Whenever an object is moving, we must have to keep a fixed point or a fixed axis, and torque can only be found about an axis, about a fixed point. So I'm considering an object O here. From this O, we are having a distance R, and there is a point here. The point is P. If some force is acting on this, this is theta. This is the R vector. Here we are having an R vector force vector here. So to get the torque, there is a formula R cross F. Torque is basically a cross product of radius vector cross product of force vector. So it's a cross product. And you know, when we are doing a cross product, so we can divide this thing into two formats. The torque is equals to R F sine theta, or torque is equals to F R sine theta. What's the difference between these two? The difference is that if I'm having F here, I can divide this F into multiple parts, F cos theta and F sine theta. So if I'm considering this F sine theta, I have to multiply this R. So basically, generally, multiple times we says that torque is equals to the R multiply the perpendicular force, or you could say that torque will be equals to, this is R, this is theta, you could take this as theta, and if this is theta, you could say this will be R sine theta. Okay, and if this is R sine theta, this is 90 degree. This is 90 degree, this is 90 degree. Okay. Now, I can also take this force multiply by this. I'll use another pen. I can use this force multiply by this. So this is generally being considered as force into perpendicular distance. Right? This definition is very much popular. That torque is equals to force into perpendicular distance. And in this, torque is equals to distance into perpendicular force. Okay. So now let's see that how we are going to approach. Similarly, you can do one thing. If you are not okay with this, you can do one thing. Take this force at this point and take this component, R sine theta. Okay. Is it clear, my dear? Now let's solve questions. Here we have a question for you. Find the torque of a force. So force is given to you. About the origin, the force acts on the particle whose position vector is given to you this much. So according to the question, we have R vector. Let me use another pen of yellow color. So R vector is given to us I cap minus of j cap plus of k cap. The force vector is also given to us 7 I cap plus 3j cap minus of 5k cap. Okay, so these are given to you. Now you have to find out torque. So torque is R cross F. And to do the cross multiplication, what you need to do is first put I cap, j cap and k cap in the first row. You have to draw the matrix. Then take the variables of the first vector. So I'll be considering 1, -1, 1. For the second, For the second one, take the values as 7, 3, minus 5. Okay. So these are the values for this thing. Now you have to open this. I cap minus 1, 3, 1 minus 5, minus of j cap, 1, 7, 1 minus 5. Please do it with me. See, here what I am doing is I am replacing for the first thing, like for this I cap, what I am doing is I am not considering this column and not considering this. Just this now if I'm not considering the first row and first column, then these values are left. So this is what I have kept there. And for the next thing, for the j cap, I'm not considering the first row and this column. Then this 1, 7 and 1 and minus 5 will be left. If I'm considering this k cap, I'll not be considering the first row and this last column. Then this will be left, right? So this is what I'm writing here: 1, 7, minus 1, 3. And now you have to open this. To open this, what you have to do is just cross multiply. Just cross multiply. Here also just cross multiply. So you will get I cap. And here 5 minus of 3. Here it's minus j. Minus 5 minus 7. Plus k cap. 3 plus 7. Okay, 3 or plus 7. Now this thing 2 I cap plus 12 j cap plus 10 k cap. So this is the torque which we are getting. Are you getting same torque? Hi Vijay Roshan and unknown gamer, moms Tanishk. Shall we move? Shall we move? Let's move. Okay, another question here from the H.C. Verma book. When a force of 6 Newton is exerted at an angle of, basically what we are doing here is, if we are applying a force in the first case, this is the force of 6 Newton at an angle of 30°, this wrench at a wrench at a distance of 8 centimeter, this is the 8 centimeter from the nut, it is just able to loosen the nut. Okay, so when you are applying a 6 Newton force at this 8 centimeter distance at this particular angle, you are just able to open this nut. What force would be sufficient to loosen the nut if you have extended this distance and you are applying this force perpendicularly? So this is what you need to find out. So basically we know that if we are loosening this nut, then we must have to find out the torque required to open the nut. So I could write here torque required. The torque required is equals to R1 multiply the perpendicular force I'll be taking. So to get the perpendicular force, what I have to do is I have to resolve this force into this component. And this component is basically nothing, it's F sine 30°. And you could write this thing as F1 is 6, sine 30° is 1 by 2. So that means it's 3 Newton. Right, 8 centimeter into 3 Newton. So torque required is 24 Newton centimeter. Similarly, here the torque required will remain same, right? 24 Newton centimeter. But here what is happening is we have increased the distance. We have increased the distance from 8 centimeter to the 16 centimeter. So I'll be considering the R2 into the force is perpendicular here. So I do not need to take the components of the force. You could write it as 24 is equals to 16 into F. So F is equals to 24 divided by 16. 3 by 2 is 1.5 Newton. So the force is required. So the new force which is required is only 1.5 Newton. Is this thing clear? This question is from H.C. Verma book. Very, very important question. I hope that this concept is clear to you. What is happening here? Is this thing clear? Please let me know in the chat. Unknown Cyber Hub. Yes. Cyber and Science Creation. What a unique name you are having. Where are you from? Next, let's solve this question. According to this question, you are installing a new spark plug in your car, and the manual specifies that it will be tightened to a torque that has a magnitude of 50 Newton meter. That means if you apply 50 Newton meter, your spark plug will get tight. Using the data in the drawing, determine the magnitude of F of the force that you must exert on the wrench. Okay. So basically, you are applying the force in this direction. This is the theta here. If this is theta, then this is 60 degree, right? What I have done is I have drawn one perpendicular here. If this is 30 degree, I know that the complete angle is 90 degrees. So this will be my 60 degree. Right? This will be my 60 degree. And now, if this is 60 degree, this will also be 60 degree. And this is the force F cos 60 degree. Okay. So to get the force, torque required is equals to, see, I need to take the perpendicular distance and the perpendicular component of the force. So that will be 50 Newton meter is equals to 0.5 into F cos 60 degree. Hundred divided by 0.5. Force is equal to 200 Newton. It's my channel name. Okay, you are also a YouTuber. Great. Now it's like every second student of mine is a YouTuber. So which type of videos you upload? Cyber and science creation? You're more fascinated about the astronomy. I have one friend who's astronomer basically, and he's like crazy about the stars and the galaxies. If you ask him that how does this star form, so he will be giving you like he will be taking 15 minutes of yours and will be explaining you that you know that what is happening there at that star. there are millions of bomb which is blasting. So he is like very crazy. Like if you ask him one question, he will be taking you 15 or 20 minutes and will be explaining you each and everything. It's very good that he'll be explaining you from the very basic, but it's sometimes it quite be irritating if you do not have interest in those things. Right, I hope that this question is clear. Now let's move to the another question. This question is very close to my heart because this is heart in this question, and in this question you have to basically calculate the total torque acting on the body as shown in the figure. So here you also learn one simple approach, that whenever we are getting a difficult question or a question in which we feel that we are not able to solve this, or it seems to be difficult, then remember one important point which I am telling you now, that take this question as an opportunity. Take this question as an opportunity and divide this question into multiple parts, in which at least a single point or a single uh, part you would be able to solve. In this question, basically, there are 1, 2, 3, and 4. 4 forces are acting. So take 4 forces. Force F1, force F2, force F3, and force F4. Okay, there are 4 forces which are acting on this. And what you need to do is you have to find out the total torque. So before getting the total torque, what you need to do is you have to get the torque due to all these individual forces. And once you are done with these individual torques, then add them up if they are like supporting each other, and subtract them if they are not supporting each other. So let me find the first torque, torque 1. For getting the torque, you know that we have to take the distance multiply by the perpendicular force. So this force is getting in this direction. You know that if you have to consider the perpendicular force, you have to take in this direction. This is F sine theta. Sine 37 degree is perpendicular by hypotenuse 3 by 5. Cos 37 degree is 4 by 5. Cos 53 degree is 3 by 5. Sine 53 degree is 4 by 5. Okay, now this torque 1 will be equals to, I will not be changing the centimeter to meter. I'll keep all the data in the centimeter only. Okay, so I could do one thing, 6 centimeter multiply by F sine 37 degree to get the torque 1. Write it as 6 centimeter multiply by F is 15 sine 37 is 3 by 5. 5 3 is 15. 3 is 9, 9 6 is 9 5 is 45, 9 6 is 54. 54 Newton centimeter. Now you have to consider the direction as well. That due to this, that due to this is moving anti-clockwise. So I'll be considering this as anti-clockwise. And this F2, due to this F2, as this force is exactly passing through the center, so torque 2 is 0. Torque 2 is 0 because this force is acting directly at the center, right? So there will be no perpendicular component for this. Similarly, for getting a torque 3, what I could do is take force here. This is the distance. Consider this as force, 30 degree. That will be F3 sine 30 degree. 4 centimeter. F3 sine 30 degree. 4 centimeter into 20 into 1 by 2. 10. 40 Newton centimeter. Okay, and due to this also it is moving anti. Now for this torque 4, we have 4 centimeter and a direct perpendicular force. Here we are having F4, 4 centimeter into 10. Then we are getting 40 Newton centimeter, and it's moving clockwise. You know, one thing, we have to, like, before getting the net force, because for net force what we need to do is we just have to add them up. But before having the actual addition, we need to provide other sign for all these torques which we have calculated. And to get the sign, generally we follow one conventional. Either you have to take clockwise direction as positive or the anti-clockwise as positive or negative. Okay, and then we can find out it. So I'm seeing here that the two values are coming anti and only one value is coming the clockwise. So I'll be considering the anti-clockwise as the positive sign. So here I am putting a positive sign here. Here also I am putting a positive sign. For the clockwise, I am putting a negative sign. Okay, and once we add them up, I'll be getting, because this 40 and plus 40 and minus 40 will get cut down, so I'll be getting a torque net is equals to plus 54 Newton centimeter, or I could say that there is a net anti-clockwise torque which is acting on this object, which is being equals to the 54 Newton centimeter. If you really wants to change this thing in the SI unit, you can do easily, because in SI unit we will be getting the torque net is equals to 0.54 Newton meter. So this is what we get if I'll change this to the SI unit. I hope that this question is very clear to you. First thing what you have to learn from this question is that how we are getting the torque. If the diagram is given, then how we could easily find out the torque. Torque can be easily find out using the distance what you are having from the particular point at which you have to find out the torque. Take the distance and take the perpendicular force, you will get that torque. Consider a positive sign or a negative sign according to the question. So here what I had taken is the anti-clockwise as positive and the clockwise as the negative. You can take the other way around also. And the another thing which is important in this question is that I have divided these questions into multiple different parts according to the forces which we were having, and then after calculating each and individual part, I have done the net calculations. I hope that this thing is clear to you. Let's move to the another. Can you explain component splitting? Yeah, I will, but if there are multiple ways to use theta and forms its components. You tell me which is not being clear to you, PCS Archer. Like here, what I am doing is to get the component, if we must have one reference. If there is a reference value. I'm taking a reference is this. This is my reference. And from this reference, I'm taking another vector here. This vector could be the velocity, could be the displacement, could be the force, anything. I'm considering it as a general A vector. And there is an angle theta. Then what will happen if this is moving here? So I'll be getting A cos theta, and here I'll be getting A sin theta. And this is not a rocket science to get how we are getting here A cos theta, how we are getting A sin theta here. Take a very simple example of the trigonometry which you have studied in class 10th, and I hope that you have studied pretty well in your class 10. Generally it happens that when you are small kid, your attention power is very high. I'll be considering a perpendicular here, base here, 90-degree sine here, hypotenuse here. So basically what is happening here, we have been provided by the hypotenuse, right? So we have been provided with the hypotenuse. What I'm taking hypotenuse as A. So if I'll use a cos theta, I'm considering a theta here. So cos theta will be equals to base by hypotenuse. Base we do not know. Hypotenuse we know. So base will become A cos theta, right? So you could write this thing as A cos theta. Similarly, if you apply a sine theta here, you will get sine theta will be equals to perpendicular by hypotenuse. Perpendicular we do not know about, but the hypotenuse we know that hypotenuse is A. So if you have to calculate a perpendicular here, you will be getting A sine theta. Okay, you will be getting A sine theta. So this will become A sine theta here. Okay, now similarly, if I'll consider this as A, this as theta, perpendicular base, you'll be getting this thing, right? I hope that this thing is clear, that how we are taking the components. Similarly here, this is the angle. For taking the component towards the angle side, I'll be getting the F cos theta, and towards the perpendicular side, I'll be getting the F sin theta. So this is what basically I'm doing. I hope that this question is clear now. Who has asked this question? Prem Kumar, very nice name. Okay, PCS Archer. So why your name is PCS? Is there any significance of this PCS or the Archer? Any significance? Any story behind this to have this kind of name? Or it's just a randomness, or a random thing comes to your mind that now now onwards my name should be like this? So let's do one thing. You know what? In life, equilibrium is very, very important. What is equilibrium? Equilibrium means that you are not going forward, you are not going backward. And now, once we are done with the torque part, I can define a pretty much effective way to get the equilibrium in physics. In physics, basically, equilibrium means that at any point, we are talking about at any point, summation of F net is equals to 0, and summation of torque naught is equals to 0. Then I can say that there is an equilibrium. If I'm telling you F net, then what does it mean? It means that a force at x-axis is 0. Summation of force at y-axis is 0. And a summation of Fz is equals to 0. Similarly, summation of torque net. If I'm telling you torque net is equals to 0, you could say simply that torque clockwise equals to torque anti-clockwise. Okay, something is moving clockwise direction, something is moving in anti-clockwise direction. This must be equal. So this is all about an equilibrium. Okay, now let's move. Here we have one question for you. In this question, a metal bar 70 centimeter long and 4 kg mass is supported on two knife placed 10 centimeter and from each ends. A 6 kg weight is suspended at 30 centimeter from one end. Find the reaction at knife edge. Assume the bar to be uniform. Okay, this is one question. Okay, let's solve this question. There is a very simple method which I'll be teaching you, and basically I'll be teaching you that how to approach this numerical. Let's draw one road. The distance is 70 centimeter. The mass is 4 kg. They are supported by two knives edges placed 10 centimeter from each end. 10 and 10. Continue this class in the next part. Sorry for making one shot into two shots, but this is the only solution what I am having currently, because with no electricity I can't use this smart board, and I'll not be like ready for taking that class from the smart laptop, right? So I'm ending this class here. I hope that you enjoyed the class till now. Please watch this class again if you are having any doubt. Some doubts were coming here that so why net torque is 0, because we want a system to be in equilibrium, and if a system is in equilibrium, it means that it's not being rotated, it's not being moving forward and backward. There is no acceleration, there is no angular acceleration, there is no translational acceleration, if simply I could say that. Okay, so this is what the circular. Okay, Vandana Kumari, I'll do that thing. So Vandana Kumari's question was that why we took torque net is equals to 0, because for the equilibrium, that is the conditions what we need to fulfill. Okay, so for sorry, I'm extremely sorry for making this one shot into two shots. I'll be continuing this lecture from here only in my next class, because there is electricity issues at my end. So sorry for cutting this class here. I'll continue this class tomorrow or a day after tomorrow. I'll take that class whenever my slot is. So I'll take this class on Friday. I'll extend the another class after that. Okay. So bye till then.